Hello everybody, this is Algebra 2 and we're getting ready to start lesson 8.1. Here's the source of these PowerPoints and videos and worksheets, test quizzes. 8.1, apply the distance and midpoint formulas. This is in chapter 8, which is quadratic relations and conic sections. And this is the opening lesson for Chapter 8 for Algebra 2. 30-point class worksheet and 18 points worth of note-taking. This is the bell work for students coming in the classroom right now, or you homeschoolers, this is your warm-up. If you need more room, attach a sheet to your class worksheet. And today's your lucky day because I give you the solution. This is a solution PowerPoint slide here. The graph of a quadratic function, quadratic, and the graph of a rational function. What kind of graph is this? It is a hyperbola right here. Okay, slide 1 of our classwork here. Before you found the slope of a line passing through 2 points, you will find the length and midpoint of a line segment so you can find real-world distances. This is kind of like the distance and midpoint formulas revisited here. Class worksheet, page 2. To find the distance between A and B, apply the Pythagorean theorem to the right triangle A, B, and C. So we're going to, and with this situation here, if it's a right angle here, we could of course use the Pythagorean theorem. AB squared equals AC squared plus BC squared here. And we come up with this. This is how we are deriving our distance formula, is by using the example of the Pythagorean theorem. And so distance here, we take the square root of both sides, radical this side, radical this side. This, the square root of d squared is d. And then here we have to work that out. So this is how we derive the distance formula. The final equation is the distance formula. You know that this will be a vocab word here. The distance between x1, y1 and x2, y2 is here. Here again is the formula here, the distance formula. Key concept, the distance formula, and here it is. And then now we define it here in our vocabulary slide, distance formula and the midpoint formula, which we have not covered yet, but hang on to it because we will cover it. This is your notebook, page 4 in 8.1 in your notebook. So have that ready on my notebook check. In my classrooms, I do a notebook check on Fridays. And here we go into example 1 here, and this is a standardized test practice format. What is the distance between -3,5 and 4,-1? So using that in front, here are possible solutions here for that. Maybe you can just look at it and tell. I don't know. Let x1, y1 be equal to -3,5 and x2, y2 be 4, -1. So we set up our distance formula here. We just plug in our values from these determinations up here into our formula here, and we come up with 49, this radical 49 plus 36, which is the square root of 85. So if you guessed C, you guessed right. What is the square root of 85, by the way? It'd be about 9 something, 9 point something. Okay, find the distance between these 2 points here, the origin, 0, 0, and 8, 15. You need to find that. And students, this is your independent practice here. So you need to do that on your own, or if I let you, you can use study groups only if I let you that. Find the distance between the 2 points here, 0, 0, 8, and 15. We do a plug-in here. 8 minus 0 squared plus 15 minus 0. That makes it easy here when you're starting at the origin. So we have 64 plus 225, radical 64 plus 225. Yes, that's where we got that. Square of 15 is 225 and 64. We get square root of 289 is what? 17. So the answer to that first guided practice will be 17. So here's a concept slide, the midpoint formula. So we remember now to go back to your vocab question about the definition of a midpoint formula. A line segment's midpoint is equidistant from the segment's endpoints. Okay. The midpoint formula is shown below, gives the midpoint of a line segment joining A and B. So here is your graphic here of finding this midpoint between A and B. Okay, there's that graphic. Here's your midpoint formula, x1 plus x2 over 2. I mean, that would be your x coordinates will be derived that way. X1 up here, then x2 here. You add those, and then you take 1/2 of that sum. Same thing with your y coordinates. You add them, and then you divide them by 2. In words, each coordinate of M is the mean, so they use the terminology here of the mean of the corresponding coordinates of A and B. So we go into another example here. Find the midpoint of a line segment. Here's our line segment here. Here's the line segment here. On a graph, we have -5, 1, and then -1, 6. What is, well, we got it here in this, we say that's that. I mean, is that true? Well, let's see. So we plug in here and we get -3 for our x coordinate here, and then 1 and 6 over 2 is 7 over 2. So according to the formula, that proves that this assumption here is correct for that. And then our guided practice number 2, using the formulas, find the distance between the 2 points, then find the midpoint of the line. So now we have to find distance and midpoint. Same thing down here, students, for your independent practice. Page 10 on your class worksheet. So the guided practice here, find the distance between the 2 points and find the line segment joining them. Here's the distance formula here. 15 minus a -5. So this is x1, x2, and then 8 minus 1, this is y1, y2 squared. So you square that sum, we get 20 squared plus 7 squared, and the radical of that of 400 plus 49. So what's radical for 49, students? We don't know. We get out your calculator. Now the midpoint, -5 plus 15 over 2. We're taking the mean now of the distances between the x coordinates, and then taking the mean of the distances between the y coordinates here. And -5 is +10 over 2 is 5, and then 9 over 2 would be the y coordinate for the midpoint of that line. Into the homework for 8.1, 124 points worth of homework. We had 18 points of notes in your classwork. So this is a pretty healthy homework assignment here. Vocab, and then writing. Probably the more you write, the better grade you'll get here. And then find the distance between the 2 points, then find the midpoint. So distance, midpoint for these. You got origins here, so that's easy. That one's fairly easy. And then page 3 of our homework, find distance and midpoints here between these 2 points. And then same thing here, page 4 on your homework, find distance and midpoints between these 2 points. If you need more room, attach a sheet, staple it, and hand it in with your homework. Page 5, distance and midpoints here. And then page 6, distance and midpoints. We have some decimals here. Be careful with those. Be careful with those. And then page 7 here is multiple choice, error analysis. And that page is worth 24 points. So that's 8.1 assignment. And if you want further lessons into Chapter 8, get a hold of me for PowerPoints or videos, worksheets, quizzes, and tests. Okay? Thank you very much.